Good morning, everybody. Today's video we'll be talking about conjugates of word sword. And in my last video I did rationalization of sword, and today I'll be starting from number 6 again to number 10. So conjugates in mathematics we have many algebraic signs, let me say signs or expressions, like the addition, subtraction, the division, and the multiplication. Now let me just say that addition and multiplication come from one family, and subtraction and division comes from another family. So now one very day, this addition and multiplication met what? Division and subtraction. Now there was an argument going on. When addition brings up what? When addition brings up an idea that will be followed, subtraction will do what? Will counter the idea and bring up its own. So everything being equal, this subtraction will now neutralize the idea of what? Addition. Now if subtraction brings up its own idea, or let me say this is a he and this is a her. If addition brings up her own idea, if subtraction brings up her own idea, addition will do what? Will counter it. And everything being equal, addition will neutralize the idea of what? Subtraction. But addition don't have that power over what? Division. Because when division brings up idea, addition doesn't know how to do what? Counter it. So on that process, addition went and called his brother, which is what? Multiplication. So now they now see that whenever division brings up an idea, whenever this division brings up idea, multiplication can do what? Can counter it. Multiplication can counter it. So everything being equal, they are going to what? Neutralize their idea. And whenever multiplication brings idea, division can do what? Counter it. Everything being equal, their ideas are gone up. What I mean now is, let's say that the idea that addition brought up was to do what? Was to add 2 to a certain number, which is what? X. Add 2 to a certain number, which is x, so that what they need will, let me say that this x is 200 in our currency is naira. So now they need something of, they need to buy something of 250 naira. So now that is the idea that addition brought up. But subtraction said no, that we are going to do what? Remove 15 naira. So now when this expression is being carried out, we still have what? Back our x. Now coming to this place, that same thing, we have what? A number x. Multiplication says we are going to do what? You're going to increase this x 3 times by multiplying it by 3. Division will say no, that we're going to do what? Divide it, and everything being equal, we still have back our x. So that is what I'm trying to explain what conjugate is. So the conjugate of a number, basically mostly in addition, the conjugate of addition is what? Is subtraction. And the conjugate of subtraction is what? Addition. So this is what we're going to be using to solve somewhat example. The example like now, we have 2x plus 3. To find the conjugate of this is what? 2x minus 3. This is the conjugate of this. Because this guy said, let us add 3 to this number, so that we're going to get another number that is bigger than this. While this guy is saying no, that if we remove 3 from that same number, we're going to get another number lesser than it. So that is what, but if you add the 2 now, we'll still get our number 2x what? Back. So now, having known what conjugate, now another one is What is the conjugate of 5? Is the conjugate of 5 minus 5? I don't know, but let us check. We know that this 5 here is, for example, let's take that this 2x. But there is another imaginary number. Let me say 5.i. So now this here now is going to be what? 5 minus dot I. So the conjugate of 5 is equal to what? 5. No matter what, the conjugate of 5 is what? Is 5. So that is it for what? For conjugates. When we'll be solving examples on rationalizing a conjugate, we'll see it. So let's go back to this. So number 6 says a root b divided by c root d is equal to a over c root b over d. What are we going to do with this now? Coming from this side, I will not say what this is a times b raised to the power 1 over 2 divided by what? C times d raised to the power 1 over 2 to be equal to a over c raised to the power b over d. Sorry, root b over d. So now I will now say that this is a over c times b raised to the power 1 over 2 over what? D raised to the power 1 over 2. That means I collected what? Like terms. To be equal to a over c raised to the power b, root b over what? D. So now this is going to give me, this implies I'm going to have what? A over c. This they have common, this thing, they have common power, so I can now say b over d all raised to the power 1 over 2. So that means I'll have a over c, the root of what? B over d. So now coming from this side again, I'll now have a over c root b over what? D to be equal to a over c bracket b over d raised to the power 1 over 2 to be equal to a over c times b 1 over 2 over d 1 over 2. So now, since this is what I want to get, I'm now going to split this one to have what? A divided by what? C multiplied by b 1 over 2 divided by d 1 over 2. Since I want to have a and what? Root b, I'm going to multiply these two together to have what? A b 1 over 2 divided by c d 1 over 2. So that means I'm going to get what? A root b divided by c root d. So having come from this side and this side, I proved that they are the same. I'm good to say that they are all what? Equal. They are the same thing. So I go to number 7. 7a root a squared equal to a equal to root a all what? Squared. So now this is what I'm going to prove this using some laws of indices. I will now say root a squared is equals to a 1 over 2 a raised to the power 2 1 over 2 to give me a raised to the power 2 over 2 to give me a raised to the power 1 to give me a. This one again, this is what? Root a all squared to be equal to what? Root a to be equal to a 1 over 2 to be equal to a 2 over 2 to be equal to a raised to the power 1 to be equal to what? A. So that is not very hard to see. Go back to number 8. Number 8 says a root n is equal to what? Root a n. So now from this number 8 now, this number 7 is a special case of this number 8. This is a special case of, but let us check, let us prove it now. This is root a over n to be equal to what? The root to be equal to a raised to the power n raised to the power 1 over 2. Now this is going to give us a raised to the power what? N over 2. This we are going to get now. Since we want to get this now, we bring out sorry, I made a mistake here. So since this is what we are going to get now, we bring in our n and take out our 2 to be equal to what? So now to express this, now we have the root of what? A raised to the power n, a digit of what? A raised to the power n to be equal to what? The root of a all raised to the power n. We have seen that they are all the same and it is equal. So we'll go over to number 9 and number 10. Number 9 says the root of a raised to the power minus m is equal to 1 over root of a raised to the power m. So now to prove this now, I will now say, coming from this side, the root of a raised to the power minus m is equal to what? A raised to the power minus m is power 1 over 2. And this is the same thing as what? A raised to the power minus m over 2. And remember, when we have a minus sign as power, it is 1 over. So now this will give me a raised to the power what? This is 1 over a raised to the power m over 2. So now I will now have that it is equal to 1 over the square root of what? M, the square root of a raised to the power m over 2. Sorry. The square root of a raised to the power what? M. And we see that it's equal. Let's try and come from this side. We have 1 over the square root of a raised to the power m. So we're now going to say 1 over what? This 1 over a raised to the power m over 2. So we want to clear this thing, and we know that from law of indices, a raised to the power minus 1 is equal to 1 over what? A. So that's what we're going to use. We'll now say this is what? A raised to the power minus m over 2. Right? And this is what we want. So now say this is what? A raised to the power minus m bracket 1 over 2. So we can now say that this is equal to the square root of what? A raised to the power minus what? M. So that is it. We'll go over to the last one, which is the number 10. Number 10 says 1 over root a raised to the power minus m is equal to root a raised to the power m. So proving this coming from this side, I will now say 1 over root a raised to the power negative m is equal to what? 1 over a raised to the power negative m 1 over 2. So now this will give me 1 over a raised to the power minus m over 2. Now remember that this here is negative, this power is negative. So I'll now say 1 over a raised to the power m over 2. So I'll now say that 1 over a raised to the power m over 2 is equal to what? 1 over 1 divided by 1 over a raised to the power m divided by 2. So this is going to give me 1 times a raised to the power m over 2 to give me a raised to the power what? M over 2. So now to express this now, I will now have that a raised to the power m over 2 is equal to what? The square root of what? A raised to the power m. So it is not very hard to see, and at this juncture, I would say this is where I will stop for today. I'm Timothy. In my next video, I'm going to be solving some examples on conjugate and rationalization of words Surds. Thank you and do have a nice day.